This is the video for problems 3 through 7 on the Core 2 Probability Rules quiz that we took a few days ago. I'm going to show you how I would solve the problems, and you can look at what you did, see if you did the same thing or did something different that might also answer the problem. Problem 3 through 7 calls for you to use the sample space that I gave you there. The sample space shows the probability of rolling a red 4-sided die and a green 12-sided die. For each possible number on the red die, there are 12 possibilities on the green die. So I have 12 possibilities if the red die is 1, 12 possibilities if the red die is 2, 12 if it's 3, 12 if it's 4. I have 12 possibilities 4 times. So I'm going to take 4 times 12 to get my denominator. There are a total number of outcomes in the sample space of 48. And for problem number 3, I'm doing red 2. And red 2 happens for all of these possible outcomes. So there are actually 12 possible outcomes where I get a red 2. So probability of red 2 is 12 out of 48. Probability of a green 11, that is these right here. There are a total of 4 of those. So for probability of green 11, I'll have 48 possible outcomes, and 4 of them have a green 11. For question 5 that says red 3 or green 11, I don't have to have both. I just have to have one or the other. And I'll look at the sample space again. I have 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12 possibilities where I get a red 2. But I also have to count the possibilities where I have a green 11. So that's 12, 13, 14, 15. And you'll notice that I skipped 2 out of 11. I have an 11 there, but I already counted that. So my probability is 15 out of 48. And a lot of you probably just said, okay, there are 12 possibilities for a red die, 12 possibilities for a 2 on the red die, 4 possibilities for an 11 on the green die. That's a total of 16. But if I do that, I count that 2 and 11 twice, because it's actually part of the 12. It's also part of the 4. So a lot of you just did 12 plus 4 minus 1. That's a very good way to do it as well. Probability of a red 2 and a green 11, and in this case, not or, and means I have to have both. It's not okay to have 2 on the red die but a 1 on the green die. It's not okay to have 2 on the red die and a 12 on the green die. I have to have a 2 on the red and an 11. 4 and 11 doesn't work. It has to be 2 and 11. And there's only one possibility where that happens. So this is 1 out of 48. Question 7 says, are the events independent? Is rolling a red 3 and a green 11, are those two events independent? If we think about the situation, if we roll the red die, we get a 3 on the red die. Well, let's say we'll get a 2 on the red die. That will not change the probability of getting an 11 on the green die. We roll the green die, we still have 1 in 4 chance of getting an 11 on the green die. So logically, we can say they're independent, but there's a way we can do that mathematically as well using the multiplication rule. And I'm going to do that as well. So I'm going to say multiplication rule says probability of red 2 and green 11 is equal to probability of red 2, which I'm going to reduce to 1/4 instead of 12/48 because I know I'm going to have to multiply. I don't want to multiply a big number. I want to multiply a small number. That's a dot. I was trying to make a dot for multiplication. Then I have to multiply by the probability of a green 11. And I'm going to reduce that to 1/12. I divide the 4 by 4. I divide the 48 by 4. I get 1/12. Then when I multiply those, 1 times 1 gives me 1. 4 times 12 gives me 48. So I get the same probability if I multiply red 3 times green 11 as I do if I just go to the table and find red 3 and green 11. If those two are the same, the probability multiplication rule of probability tells us that the events are independent. So when I fill out my answer to question 7, I would say the events are independent and then use one of those arguments to fill in the part after because.